Hello friends, welcome to Joy of Life. So today we are again going to look at a medium level problem from Leetcode. The problem number is 863. It's all nodes distance k in a binary tree. So we are given with a binary tree with the root node denoted by root, a target node and an integer value k. To return a list of the values of all nodes that have a distance k from the target node. The answer can be returned in any order. So let's look at the example given in the problem. So here is one example wherein we are given with a tree. So the root is 3, then we have two childs 5 and 1, 6 2 is the child of 5, 0 8 is the child of 1, then 7 4. Okay, so our target node is 5. So this is our target node, and we have to give all the nodes which are two distance out from it. So this is one distance, this is one distance, this is one distance. Uh, this node over here, which is two distance out. These two nodes are three distance out. So basically, how you find that out is how many steps you have to take outside. So from 5, I can go to 3, one step. From 3 to 1, another step. So this is two steps out from 5. Similarly, for 0, 5 to 3 is one step, 3 to 1 is the second step, and 1 to 0 is the third step. And similarly, here also we see that 5 to 2 is one step, 2 to 7 is the second step. Similarly, 5 to 2 is one step, 2 to 4 is the second step. So given the node 5, which is at level 0, I'll say, these are the distance of the different nodes. So our answer should be only where the distance is 2. So we see the distance 2 is present over here, one over here, the other over here. These are all two steps out. So our answer is 7, 4 and 1. It could be in any order. So here also it is 7, 4 and 1. Okay, so this is the problem all about. Do give it a try yourself before looking at the solution. And let's head over to the board and look at the solution. So I have taken the same example from the Leetcode problem, and we have created the tree. So here our target node is 5, and we are looking for nodes 2 level outside. So we are looking for a, let me put it over here. So we are looking for a level 2. So from 5, if you see, I have just marked with different colors. All the level 1 nodes are denoted by the yellow color, and level 2 nodes are indicated by white color, and level 2 nodes outside are indicated by blue color. So we'll see how it goes. So we'll just create a copy of this tree. So I'll just explain it briefly over here. So we are going to mark the levels over here. So first I'll mark green with level 0. So this is my level 0. Okay. Now coming to level 2, level 1, sorry, is the nodes that are one level outside. So let me mark it over here. And then we have the level 2 nodes. So all the nodes inside the white boundary belongs to level 2 and below. And similarly, we have another level over here, which is level 3, which will basically comprised of all the nodes in the tree because we don't have anything belonging to level 4. So let me mark it over here. So basically, if you look at this problem, so what are we dealing with over here? We are dealing with every layer. So 5 itself is one layer. Then we have the next layer, which comprised of all the items that is directly connected to 5. Either directly connected to 5 or directly connected by 5. And then again, we have the next layer wherein we have the nodes like 741, which are connected 2 levels down 5 or 2 levels up 5. So let's say we are considering level 1. So one step out of my target node, that is 6, 2, 3. two levels outside. From 6, I cannot go any further. From 2, I can, 7 and 4. So another path could be 3, and I can go another level outside, which is 1. And 5 also is, since 5 is already visited, so I am not considering 5. And similarly for level 3, we don't have any paths in this direction to go 3 levels down, but here we can, level 1, level 2, then level 3. Okay, your answer will look like this. So if I take the level value as 0, 5 would be my answer. If I take level 1, 6, 2 and 3 should be my answer. If I take level 2, 7, 4 and 1 is my answer. If I take level 3, 0 and 8 is my answer. So if you look at this problem very closely, so at any given node, say I have a node A. So for level 1, what are we checking? We are checking it's both the child, say B and C, and its parent, let's say it's T, right? But the problem is that in a tree we can come from this direction to this direction, but we cannot go from this direction to this direction because we are only considering the child. We cannot go from child to the parent, right? So that is the problem, and that is the problem we need to address here. So what we need to do in order to do that? So what do we need to do in order to address this problem? So let me make some space for us over here. So what is the problem over here? The problem is that we don't know the parent and there is no chance for me to traverse from the child to the parent. This path, this relation has to be established. So how it can be established? So what we can do is we can build a map which is having a node. Okay. So what will happen? What will this map consist of? So this map will consist of the parent mapping. So if the node is 3, the parent is null, right? Because 3 is the root node, it doesn't have any parent. If it is 5, the parent is 3. If it is 1, the parent is 3. If it is 6, the parent is 5. If it is 2, the parent is 5. If it is 7, the parent is 2. If it is 4, the parent is 2. If it is 0, the parent is 1. And if it is 8, the parent is again 1. So what it did basically, so it has established a relation for me wherein I can check the parent of any node. So what we have essentially done is we have established this mapping. So given a node 2, if you ask me what are the childs, I know what are the childs. You ask me what is the parent, I straight away go to the map and get this value. And I know that my parent is 5. So what I'll do is I will use a queue and I will do a pretty much the same thing as a level order traversal. So first what I'll do with this queue is I will go ahead and put the target node inside it. So what is my target node? I'll put 5 as my target node, right? Because we are doing for 5. So what I'll do next is I will go ahead and ask 5 that who's your left child. So it'll give me 6. I'll ask who's your right child. So it will give me 2. I'll ask who's your parent. So it can check on this map and say that, okay, 3 is my parent. So 3 is here. So we have completed exploring 5. Do is we cut it over here. Okay. So what happens is now I put 5 into a set called visited set and I put 5 there. Okay, because 5 has been completely explored. Its left child, right child, and parent has been explored. Now I start popping out from the queue again. So what I do, I ask 6 that who's your left child. It's null. I check for the right side. I get a null. I ask for its parent. I get a 5, but which is already present in this visited set over here. I do. Um, I pop out 6. So I don't get anything from 6. Its left child, right child, and parent all has been explored or not present. So as left and right child is not there and 5 is already explored, so we move on. So 6 is also removed from the queue. And what happens? We move to 2. We ask 2 who's your left child? It gives me 7. I ask who's your right child? It gives me 4. Then I uh, uh, ask for its parent. It gives me 5. I see that it's already being explored, so there is no point adding it. So I just pop it out. Then I come to 3. I ask 3 for its left child. It gives me a 5, which is already in the visited set. So I ask for its right. It gives me a 1, right? So we get 7, 4, and 1, and this is popped out. Now, whatever, so this you consider as level 0, this is level 1, and this is level 2. So if you look closely now, you will see that whatever is remaining on the queue is my answer. And if you check at every level that we found the answer mapped to the corresponding level. So if you wanted to check for say level 3 as well, so what would have happened? So we have asked for 7's left child, right child, wouldn't have got anything. 4's left child, right child, wouldn't have got anything. 7's parent and 4's parent is 2. So I just, my bad, I missed adding them to the visited set. So 6, 2, and 3 would have been added here, right? So didn't get anything from 7, I added to visited. I didn't get anything from 4, I added to visited. I go to 1 and ask for its left child and right child, right? So what I get, so these are popped, right? I did not get anything from them. So from 1, what would have I got? I got a 0 and a 8, right? And what what I would do is add 1 to the visited set. And if you look closely, this these all have been popped out, and this is my level 3, which is same as this guy. So this is all about the solution. So we'll head over to the Leetcode and try out the solution. So what we are supposed to return is a list of integer. Let's call that result, which will have the final result at the end. And at the end, we are going to return this result back. And what we are going to do is we are going to create a array list. The second thing that we need is the map, which will have the parent mapping store. So tree node, and let's call this as a parent lookup map. So let's call it just parent lookup. Let it be a hash map. Okay, and so we'll create a void method over here, which is more of a helper function who will help us to build this map. So what we are going to do in this function, so we are going to put those mapping. So build a parent map, let's call this. And what we need is the tree node for a particular node. What I need to store is the parent, right? So I'll just say this is parent, and of course we need to populate this map. So we need to have this map as well as a parameter. So what are we going to do? We are going to call this method over here. So we'll just call parent build up map, and we are going to pass the root. And for root, I know the parent would be null, so there is no parent to the null, and the parent. So there is no parent for the root node, so we are passing a null and the root node. So what we are going to do over here, first is we should have a check because we might get a null. So if node is null, then in that case we are not going to do anything. Okay, and otherwise what we are going to do, if parent is not null, so parent, if you remember, just we called with a null, right? If the parent is null, then we don't need to put any mapping there because we don't want to unnecessarily put a null value inside the map. So let's say parent lookup dot put. So if the parent is not null, so we are going to put the node along with its parent, right? Otherwise, how this function will go, this will go into a recursion. So we are going to call the same function, right? And we are going to call the same function for the left And what will happen? So we'll call the left, right? So when we call the left, who becomes the parent? The node, the current node that we are in, it becomes the parent. So for example, let's say we are at node 5, right? So we are at node 3. Let's say we are the root node. So we passed null as a parent and 3 as the mapping node. So when I get a null, I call the left subtree, means I call 5. Now what should I pass as a parent? I should pass 3 as a parent. When I call 6, what I should pass as a parent? I should pass 5 as a parent. And and that's the same thing that we are doing over here. So we are calling nodes left child and passing node as the parent, and this map will be passed as is. So we'll do the similar thing for the right node as well. And we have the preventive check. So when null is passed, the recursion will be broken at that point of time. So what happens at this point is we have the map. We are going to store 3 nodes only in the queue. So let's call it just queue. So it's a linked list implementation for the queue, and we are also going to track our visited nodes, right? So we need to store the visited also over here, which is initially empty. We are going to iterate until the queue is empty, and we are going to add the child and the parents to the queue. And if you recall that we talked about a level order traversal, because whatever is present, we should take that out and consider that it belongs to that level itself. So we are going to get the size of the queue at every level. So what we are going to do is we are going to check all the elements that we are getting from the queue, and here we are going to get the node out. So once we get the node out of the queue, what we should do is we should add it to the visited set, because we are exploring this node, and we should put that into the visited set. And what we should be checking is now that it's left child and the right child and the parent, right? So what we are going to do is if node dot left, if it is if my node left is not empty, and it is not been seen earlier, so visited, not of visited contents, node dot left, that means this node is eligible to be added to the queue. So what I'm going to do is I'm going to add node left if this condition is satisfied, and same thing I'll be doing for my right side as well. So for right also I'll check it should not be null and it has not been seen or explored earlier, and if both the conditions are satisfied, I am going to add the right node and the left node into my queue. Okay, now comes the time for the parent. So first we need to check that we have created a map over here, right? Parent lookup map. So if parent lookup map contains this node, that means that we have the information about its parent. So we should also and we should ensure that the parent is not contained in the visited. So not of visited, again the same condition, contains parent lookup dot get of node. So what I am ensuring that parent lookup map contains information about this node's parent, and it has not been visited earlier. So here I checked with the key, here I got the value and checking against the value that it has been visited or not. If both the conditions are properly satisfied, what I'm going to do is I am going to add this node, the node that we checked over here, in my queue, right? And that is all. And what we are going to do is here we are going to increment my level every time. So this level will indicate me that what is my current level, and at any point if we see that the level is same as the level that we are searching for, that means that when we are at level 2, so when we are at level 2, what we'll be doing, we'll be popping out 7, 4 and 1. So we'll be popping out and adding the child and the parents of the same. So along with that, what if we add them to our results as well? So whatever is happening, let it happen, and at the same times we are also putting the uh, putting the values of those nodes, not the child, into my results. Okay, and now we need to terminate also. So what we can do is we can leave here, but there could be like thousands of level, and we may be looking for only two or level three. So I don't want to continue with the loop anymore. So if I see that my results is not empty, so at any point, if my result is not empty, what I can do is I can just break out of it. So initially this result is empty, right? It has no elements. So only at that particular level, what it will do is it will add all the child. So let's say my level is 1. So when my level is 1, what I'll be popping out of my queue, I'll be popping out 6, 2, and 3 only from the queue. So this will only give me 6, 2, and 3. Though it will be adding the childs and all, but I don't care. For that level, what I needed is the results that I have collected and put into the list. Okay, so let's run this code and check. Sorry, I've written it as result. Let's change it to results. Well, let's submit for a broader range of test cases and see how it goes. Okay, so as you can see that it has been accepted, and we have got around 14 millisecond, better than almost 78% of the submission. Again, I won't go into that. This is just for reference. But this is the whole algorithm that I wanted to demonstrate over here, how we are putting, how we are traversing layer by layer and using a queue in order to come up with the desired result, right? So we are just using two data structure over here. So the visited set, this is a set, and this is a queue, which is a linked list. And we are also doing some of the pre-processing over here, and our pre-processing result is stored into a map. We are using them in order to come up with the solution. So I hope you like the video. Do let me know. Do put a comment. Give me a like if the solution was helpful to you, and do share and subscribe. And thanks once again for watching the video. Hope to see you guys soon again. Bye bye and have a great day.